All right, here we're going to test independence of women in the 71 to 80 age group. And so in the lesson, they talked about there's two different equations you can use to test for independence. And they both start off with this, which is the conditional probability formula. You have to calculate that in order to test. So what I'm going to do is find the conditional probability in these two different scenarios. So over here, let's do the probability of being a woman given that you're 71 to 80. And over here, let's do the probability that you're 71 to 80 given that you're a woman. So I'm just going to substitute these in to the formula so we know what we're working at. This is probability 71 to 80, and this is probability woman and 71 to 80. So if we do the first one here to calculate this, the probability that you're 71 to 80, so we're just looking at this, so it's like given that you're 71 to 80, so we're just looking at that row, the probability that you're 71 to 80 is 0.52. And then if you're a woman and 71 to 80, that would be 0.27. So let's divide those two, and if you do, you get 0.519 or 0.52. So all this is doing is it's saying, substituting now into this formula and seeing if it equals this. So the probability of being a woman given your 71 to 80, we said is 0.52. The probability of being 71 to 80 is 0.52. And if we multiply those together, we get 0.27, which is the probability of being a woman and 71 to 80. So they appear to be independent in this case. So now let's do the one here on the right. So probability of being 71 to 80 given you're a woman is, we substitute into this conditional probability formula, you put the probability of being a woman in the denominator, whatever you're given, and the numerator would be 71 to 80 and being a woman. So we have to calculate this so we can substitute it into the equation. So the probability of being a woman, so now we're looking at this column. Probability of being a woman is 0.59. The probability of being a woman and 71 to 80 is again 0.27. So if you put those two, put that division problem in your calculator, you get 0.46. Now we have the probability of B given A, and we can substitute it into this equation to test for independence, multiply this to see if it's equal to that. So the probability of 71, 80 given being a woman we found was 0.46. The probability of being a woman is 0.59. And if we multiply it, it's 0.27, which is the probability of being a woman and 71 to 80. So yes, they appear to be independent using the second equation for independence as well.